In this lecture, we will look at a recap of what we learned in this section of the course. This section taught us the basics of computer science. First, we learned what computer science is. Computer science is the study of computers and computational systems, and computer scientists write algorithms, step-by-step instructions for the computer to execute in order to solve a problem. Next, we learned what programming is, and the role that it plays in technology. Programming is writing instructions that the computer will follow to process data into information. Programming allows developers to solve problems and empowers them to create software. After that, we learned about the 5 generations of programming languages. The 5 generations of programming languages, from 1 to 5, are machine language, assembly language, high-level languages, problem-oriented languages, and natural languages. The first generation of programming languages is machine language. The second generation of programming languages is assembly language. The third generation of programming languages is high-level languages. The fourth generation of programming languages is problem-oriented languages or very high-level languages. The fifth generation of programming languages is natural languages. Then, we learned about what Python is and why learning Python would be very beneficial to you. Python is one of the most popular programming languages in the world. Once you know Python, you can apply to thousands of jobs that pay $80,000 or over. Python is used across several industries, including data science, back-end programming, and game development. After that, we learned what happens under the hood of the computer when you run a program. The computer only understands the values 0 and 1, aka binary code. When we write code in Python or another programming language, that code is called source code for the program. To get from source code to binary code, the computer must perform a few steps of translation. First, the computer translates the program from source code to assembly language. Next, the assembly language is translated into machine language. Finally, machine language is broken down into binary code, 1s and 0s that the computer can understand. There are 4 steps to running a computer program, and the process is cyclical. The steps are fetch, decode, execute, and store. The computer will fetch the next installation from the RAM, the computer's random access memory. Then it will decode those instructions, so that it knows exactly what to do to perform that step. After that, it will execute that task. Finally, it stores the result in case it needs to access it later. That is a brief overview of what happens under the hood of the computer when you run a computer program. Next, we learned about the stack and the heap. Both the heap and the stack are memory locations inside of the computer. The stack is managed by the computer, and the programmer does not manually do anything with this memory. The heap is a block of memory for the programmer to allocate and deallocate. It is important that the programmer remember to free up memory once it is no longer needed, else a memory leak can occur. After that, we learned how to get the most out of this course. How you take this course is up to your prior knowledge, goals, and your learning style. Don't look at the length of the course as intimidating. Look at it as an opportunity to master Python programming. Finally, we looked at some tips to make you the best programmer you could be. I offered you 5 tips, which were be persistent, stick to a routine, focus on the fundamentals, build hands-on projects no matter what level of experience you have, and don't be afraid to ask for help. Follow these tips and stick with this course, and you will go from beginner to expert in Python programming. In the next section, we will download, install, and set up PyCharm on your computer.